Well, hello again. Welcome to the next part of our study of energy. We're going to kind of be sticking with some of the ideas that we've been talking about recently. In our last lesson, we looked at a roller coaster, which I think is kind of a fun little application of mechanical energy, generally kind of going back and forth between kinetic energy, where you're going real fast, to gravitational potential energy when you're going up high. If you think about it on a roller coaster, if you've ridden one or even seen one, you don't go fast at the same time you're up high. Usually when you're up high, you're going kind of slow. And then when you want to build up speed, they take you down a big hill. All of that wonderful gravitational potential energy gets converted, transformed into kinetic energy, which we relate to speed. Well, what I want to do in this lesson is go into a little more detail about how potential energy is related to height and how kinetic energy is related to speed. I'm going to give you formulas to actually calculate each of them, and you can see how it fits in there. So this will be very consistent with what we've talked about with these two, but just a little bit more detail. Then we'll practice doing some calculations yourself. Okay, so let's start with kinetic energy. So I'm going to give you, again, we would call this a formula or an equation, and we usually write it this way. And this causes students some problems at times, but when we do multiplication in math, we don't typically write a times sign in between the things we're multiplying. We can just write them next to each other. Think about formulas you've used in geometry class, for example, or other math classes, like the formula for the volume of a cube or a volume of a rectangular solid. It's length times width times height. So we would just write LWH, right? So for kinetic energy, we're multiplying these three things. The number 1/2, or we could write it as 0.5 if you're using a calculator. And then M stands for the mass measured in kilograms, okay? So you want to always get your mass in kilograms. We generally, in our class, we deal with big things, you know, that have masses in the kilograms. Like you might be 50 kilograms or 70 kilograms. In a small laboratory situation, we might have grams, and we got to mess around with converting it. And then V here stands for, we use V, but we really mean speed. So V is the speed. We don't use S ever as a symbol because it looks too much like a 5. So V is like the symbol that we use for velocity. So we're really just putting the speed in place of V, and it's good enough, okay? So the thing you got to be careful of here is when you're doing this multiplication, this is a squared. That means you multiply the V again, okay? So we could write this 1/2 times M times V, all right? You don't square everything. So don't hit the equal sign and then square it. You hit the squared only for the speed, okay? And what will this give you? This will give you the kinetic energy in units of joules. We talked about that as the way that we describe energies in units of joules. There's other units too, but we'll use joules when we do this calculation. So let's just take an example. Maybe I'm a person walking down the street, okay? So we might say, for example, number 1, find the kinetic energy of a 50 kilogram person walking at 1.5 meters per second. And yeah, we'll use decimals sometimes. Be good to have a calculator or Desmos if you're working on a Chromebook or a computer. Now, I want to remind you, it's been a while since we've done formulas. You always show 3 steps, okay? So I'll reinforce that here. 3 steps. 1 is to write the formula, okay? So we write the symbolic formula. KE equals 1/2 mv squared is how we say that, okay? Step 2, you substitute in the values that you're given for each of those symbols. So the 1/2 is always just 1/2. And then our mass will be in the kilograms, so that's 50 kilograms. Now I am writing little dots in between it here because now I'm putting numbers in. When you put numbers in, it is nice to separate them with little dots. Dots just mean multiply. And then we have 1.5 meters per second. And then I'm squaring that. I put that in parentheses only because I have the units here. I want to make sure that we can see that it's the number and the units both that get squared. Okay. And then I grab a calculator. I could probably figure this one out without, but I'm going to punch it in the calculator. So for the 1/2, I'm going to put in 0.5. You can kind of maybe see here. 0.5 times 50 times 1.5 squared. Okay. 56.25 is what we get there. Now you could round that, but it's only 4 digits, so it's not that bad. And always put the units when you're done. I like to put a little box or a circle around the final answer. That's how we calculate a kinetic energy. Okay. Now we could mix this around a little bit. Maybe in another problem, I'll give you the kinetic energy, and you might have to figure out the mass. Right? So kind of be working backwards. So we may see that when you practice a little bit. All right. Now let's move on to do a practice with the gravitational potential energy using the formula I'll show you next. So we can turn to a fresh page here on mine. You might have enough space left. So here's how we calculate gravitational potential energy. Remember what we're talking about here is the potential that something has to move when it's up high. Because if you drop it or if it falls or something like that, then it's going to build up some speed. And remember, energy, you think of it as the ability to cause a change in something or to cause damage to something. And when you're up high, you can definitely cause a change to something if it falls, right? It could smash something, it can smash itself and break. So we need some height. We also need some gravity, okay? So here's our formula that we use for GPE. Again, this is in joules. And it's 3 things multiplied together. M, G, and H. Okay? So here again, mass in kilograms. It kind of makes sense, I hope, that if you've got 2 things that are held up high, one really heavy and one really light, that the heavy thing has a whole lot more potential to cause some damage if it were to fall on you. I'd rather be hit with a ping pong ball falling from a height rather than a bowling ball, for example. The only difference there is the mass. All right, G causes some problems. So I describe it this way. You'll hear it described differently in some textbooks. The strength of gravity. So when we are on Earth's surface, because gravity is not just a number that's the same everywhere. Depending on where you live, where you are, what planet, moon, wherever you are, there's different measures of gravity. There's even gravity in space. A lot of people think gravity doesn't exist in space, but it certainly does. So here on the surface of the Earth, we use 9.8. That's my reminder, sorry. 9.8. So that's the number. And then I like to use these units, newtons per kilogram. Newtons, you might recall, is our unit for force, and kilogram, of course, is the unit for mass. And H is the height in meters. Okay, so you got to get the units right in order to end up with the proper number in joules. Okay, so let's take this same 50 kilogram person and have him climb a ladder that's maybe 2 meters. 2 meters would be kind of high, but let's imagine he's 2 meters high. So example number 2. Find the GPE of the 50 kilogram man standing 2 meters above the ground. And we'll always assume we're on the Earth's surface or near the Earth's surface at least. It doesn't matter if you're 2 meters above the Earth's surface, it's still 9.8. But if we go to another planet or we go way, way, way high above the Earth's surface, that would be a little different. Then 9.8 gets a little lower. So 3 steps again. We write the formula, m times g times h. We plug in the values that were given. So we got a 50 kilogram mass. Make sure you get things in order. Don't put your g first if you wrote m up here first. On the Earth's surface, we will always use 9.8 newtons per kilogram and a height of 2 meters. And so I'll grab my calculator again. I'm going to multiply these. So 50 times 9.8 times 2 gives us 980 joules. Put a little box around it. Interesting. That's about 20 times as much energy as you have when you're walking. You can do more damage when you fall on something from 2 meters high, right? Okay. Again, I could make this a little bit different. Maybe I'll give you the energy in joules and you have to calculate one of these 3 quantities here. That would just be a little variation on this. So, okay, so you're going to have to know those formulas, be able to use them, show me the 3 steps. Very similar to how we did formulas before. So that'll get us started, and then we'll have a couple more tools now in these equations that we can employ when we do some additional roller coaster kinds of problems. That's going to be coming up. All right, thanks for watching. That's it for now.